To commemorate this International Year of Astronomy, 3 of NASA's flagship observatories have put a new spin on how we see the Pinwheel Galaxy.
The Hidden Universe Showcase explores exciting new results in infrared astronomy from NASA's Spitzer Space Telescope, with your host, Dr. Robert Hurt.
You might be hearing a little more buzz about astronomy these days. That's because the International Astronomical Union and UNESCO have designated 2009 to be the International Year of Astronomy. What's the occasion? This marks the 400th anniversary of looking at that with one of these. In 1609, Galileo first turned a telescope towards the heavens and began reporting things that would forever change the way we view the universe.
To commemorate the anniversary of this new way of seeing the sky, NASA's great observatories have teamed up to give us a whole new way of seeing the famous Pinwheel Galaxy, M101. In 400 years, technology has advanced almost as much as our understanding. Today, astronomers routinely scan the skies with spectacular telescopes, many of them seeing kinds of light that Galileo didn't even know existed. In the 1970s, this photographic exposure of the Pinwheel Galaxy from Kitt Peak National Observatory was one of the best of the time. Larger telescopes and advanced digital detectors have continued to improve the view over the years. Space-based observatories have brought amazing new ways of seeing the familiar objects like M101, as with these recent images from the Spitzer Space Telescope, the Chandra X-ray Observatory, and the Hubble Space Telescope.
The combined image represents 3 different parts of the spectrum, spanning X-rays, visible, and infrared light. But how do we make an image we can see using light we can't see?
The human eye is a remarkable biological instrument that detects electromagnetic radiation, or light. The eye's cone receptors come in 3 different varieties that let us independently perceive 3 different sections of the light spectrum, what we call red, green, and blue. All the other colors we recognize in the visible spectrum are just combinations of these 3. While the full spectrum of light extends far beyond what we can see, our sun is brightest right in this range. That's not surprising. Millions of years of evolution should produce eyes that take maximum advantage of what the sun provides. If humans were to evolve around a cooler, redder star, their visible light would include what we call infrared.
While they might even think of color the same way that we do, their reds, greens, and blues would be entirely different than ours. So, why not use technology to change our colors around too? Because of the way our eyes work, we can break down any color image into its red, green, and blue components. But the colors we display can come from any part of the spectrum.
For instance, this Spitzer image of the Pinwheel Galaxy draws the imagery entirely from the infrared spectrum, but presents them in human-friendly colors. We do the same thing with this Chandra image, but now we're using X-ray observations as the source. The colors we see now mean something entirely different than they did in the Spitzer image.
This is sometimes referred to as a false color image, but that makes it sound like there's something fake about it. Instead, it's better to think of these as representative colors, stand-ins for real colors that we can't see ourselves.
In contrast, we might say this Hubble view of M101 is natural color, since it represents the colors more or less the way our eye would see them, assuming we could actually see something so faint and tiny.
This new image goes even further, combining each of the previous observations into a single view. Blue features represent X-rays, while the red colors are infrared. Visible light is yellow, which itself is a combination of red and green. There isn't a formula that tells us exactly how to assign these colors. Art and aesthetics have a role to play along with the science.
We could make a slightly different choice for representing the colors in these observations. This version emphasizes different features and has a different visual impact. Some people may like this one better, even though it's showing exactly the same data.
400 years ago, all Galileo had to explore the sky was a small telescope and a big curiosity. But today, the heavens are just a few clicks away, and with a richer color palette than Galileo could have ever imagined. For the Spitzer Science Center, I'm Dr. Robert Hurt, reminding you that there's a hidden universe that, with a little digital help, everyone can see.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena. The Spitzer mission is managed by NASA's Jet Propulsion Laboratory.